LearningMeasure.tv.
Science and engineering podcast with emphasis on measurement. Brought to you by David Archer and LearningMeasure.com.
Episode 9. Introduction to Probability. Hello. I'm David Archer, owner of LearningMeasure.com and LearningMeasure.tv. This podcast is published by TradePub.com, GoToMeeting.com, and is part of the Blueberry community of podcasts. This week, I want to discuss a little probability concept. But first, I want to tell you a little problem we're having here. I'm in the Las Vegas area right now, and right outside this building, last I checked, the temperature is about 118 degrees. Currently, the air conditioning is not working in this building, so it's pretty hot in here. So if I look like that I'm getting sweatier and sweatier as time goes on, that's probably because I am. Anyway, we want to talk a little bit about probability today, and I'm going to try to keep this short as I can because of that. But first, I want to say something a little bit about last episode. I said it, I thought something else, and anyway, I got skew, positive skew, negative skew backwards. I explained, okay, this is negative skew because the tail has more in it, and the opposite is true. Something like this is positive skew. I knew that. I said one thing and drew the other, and I don't know why. But anyway, that's just a little errata thing. And there were some other errors in there with last week, but we'll probably correct those in a later one. Want to talk a little bit about probability, discrete probability. If we have a coin, we can flip it. If it's a fair coin, there's two outcomes, heads or tails. And we'd like to say that for a fair coin, the probability of heads is half, probability is tails are half. We're not going to try to define probability here. You can look it up. Problem with probability, it's difficult to define, and there's some controversy on how you define it. But let's say you know what that means, and the probability is heads and tails is 50%. Well, notation you might use is probability of heads is 0.5. The probability of tails is 0.5. This is some standard notation. So let me flip the coin, let's say 10 times, and I'll write down the outcomes. So we've got a tails. Now let's do it this way. Tails, heads, that wasn't a real good flip. There's another heads. There's another heads. Huh, interesting, that's another heads. And there's a tails. Do 3 more just for fun, just to make the numbers easy. Another heads. Whoop, went way over the edge. And that was tails. Okay, so I flipped it 10 times. So I've got 1, 2, 3, 4 tails, and 1, 2, 3, 4, 5. Whoops, I get it 9 times. 5 heads. Did I do that right? Oh, I forgot. Let's see. 1, 2, 7, 8, 9. Oh, that's 9. Let's flip it one more time, just to see what happens here. Heads. Okay, so there's 6 heads. 4 tails. So you could conclude maybe this measurement of the probability is that 4/10 of the time it's tails and 6/10 of the time it's heads. Well, I can guarantee you that if I flip it more and more, This will get closer and closer to half, unless this coin's not fair, and I have no reason to believe it's not. Well, what is the probability of doing 2 heads in a row? Well, if the coin is fair, there are actually possibilities, right? You can get a heads and a heads and a tail and a heads, or tails and a tail. So if you're just looking at this, if all of these are equally likely, the probabilities of each of those events is 1/4. Well, for independent events, heads or tails, it's the probability of heads times the probability of heads gives you the probability of 2 heads, which is 0.5 times 0.5 equals 0.25, which is 1/4. What's the probability of getting a head and a tail? Well, a head or head, that would be what's the probability of getting a head and tail, or tail and head. So probability for independent events of heads, well, it's 2 events, A, independent events, and B equals the probability of A times the probability of B. That's for independent events. We'll talk about dependent events in a minute, or non-independent events. Well, what's the probability of getting a head and, at least one head and one tail, or a head and a tail? So that's the probability of getting a head and a tail, or a tail and a head. The probability of A or B equals the 4 mutually exclusive events is P of A plus P of B, which equals, in this particular case, is 1/4 plus 1/4 equals 2/4 equals 1/2. So as you can see, half the choices here have one head and one tail. Okay, we're going to talk, what about other independent events? We'll talk about conditional probabilities first. This is all leading up to something maybe next week, I hope. Deck of cards, 52 cards, 2 through ace, 2 through 10, jack, queen, king, ace, 4 suits, 52 cards. What's the probability of, let's say, drawing an ace on the first one? Oh, I drew a 9, but that's okay. Probability of drawing any card first is 1 out of 52. Okay. Probability of drawing a black card is what? 16. Wait a minute, no. Yeah, 26 out of 52 equals 1/2. Probability of drawing an ace is 4 out of 52. Okay, assuming it's well shuffled. Okay, let's say I draw a card, whatever it is. Let's say I drew an ace. Now let's find one. Just for fun, okay, I drew an ace out of the card deck. Well, okay, probability of drawing an ace is 4 out of 52, right? Well, I won't reduce it at this point. But now what's the probability of drawing another ace? Well, it's not 4 out of 52 anymore, because we've already drawn an ace. So we say the probability of an ace is 4 out of 52, but we talk about the conditional probability of drawing an ace, given that we've already drawn an ace now in this case, is 3 out of 51. There are 51 cards remaining, and only 3 of them are aces if I drew an ace first. So this is the notation for conditional probability. Let's say I wanted a probability of drawing a blackjack. Okay? Probability, which is an ace and a face card. So let's say we drew an ace. Let's say a probability of drawing a blackjack if the first card's an ace. Well, probability of ace is 4 out of 52. Probability of getting a face card given that an ace was drawn, okay, well, how many face cards are there? Jack, Queen, King, 10, well, or a 10, face card or a 10 or a face card to get a blackjack. So it's 10, Jack, Queen, King, 4 of those, 16. It's 16, there's 16 of those in the deck still, out of not 52, but 51. So the probability of drawing a blackjack when the ace is drawn first is the probability of first drawing the ace times the probability of drawing a face card given that you've drawn an ace. This is what happens when, so we got P, for independence, PA and PB. But the probability of A and B for dependent events, the probability of A and B, this I'm going a little fast here because it's very hot, is probability of A times the probability of B given A. Okay? Now the probability of A or B, what if there's a probability of A or B? What's the probability for non-mutually exclusive events? What is a probability of A or B? In this case, probability of, let's say, drawing an ace, and then the probability of then drawing a spade. Well, it depends in a way, because they're not mutually exclusive. You can draw first the ace of spades. So the probability of A or B is the probability of A, in this case, plus the probability of B, minus the probability of A given B, or sorry, B given A. Okay? So the probability is different for, in the case of this card example, probability of drawing an ace is 4 out of 52. Probability of drawing a spade is 1/4. Probability of the drawing an ace of spades reduces, this is given an ace of spade was drawn, this probability is now 12 out of 52 of drawing a, 1 out of 52 is what's left over. So you have one less chance of drawing a spade if you draw that ace of spade first. Okay. The other thing I want to talk about, once you have two events, if you only have two events, two discrete events, that's governed by what's called the binomial distribution. And here it is. And where, if you can see, we'll come back to that in a second. And it has some terms like this. Well, that's read n factorial. What this means is n times n minus 1 times n minus 2 times ... to 1. Okay. So where does this come from? Well, where it comes from, let's say you have, you have 4 different colored beads. Let's say they're red, green, blue, and yellow, let's say. Okay. What are the different ways you can pick that you can arrange these? Well, there's 4 ways you can pick the first one. There's 3 left. So there's 3 ways you can pick the second one. There are 2 left. There's 2 ways you can pick the second, that one. And then there's only 1 left, so there's only 1 way. So that's 4 factorial ways you can arrange 4 independent objects. That's where it sort of comes from. Okay, so here's a distribution again. R is the probability, the R in this equation, R is the number of that you want. Let's say you want R, let's say A is heads and B is tails. N is the, say you want to flip it 100 times, N. R is the number you expect. So R could be, let's say you want, what's the probability of 100 out of 100? Well, that's a really small number, and you can figure that out with this equation. Okay, moving along, we'll try to get through this quickly. Before we do that, I got to pay some bills. If you're looking for a better way to present or collaborate during your conference calls, your solution is simple. Web conferencing with GoToMeeting. During your call, everyone logs on to GoToMeeting.com, and your computer screen shows up on their computer screen. It's like you're in the same room. GoToMeeting is perfect for sales or product demos, real-time collaboration. Plus, you're not charged per minute like other providers. You can meet as often as you want, as long as you need. With GoToMeeting, you can meet with anyone, anywhere, without leaving your office. You'll not only save time, but money too. See for yourself. Try GoToMeeting free for 45 days. Just visit GoToMeeting.com/podcast. That's GoToMeeting.com/podcast. Try GoToMeeting today. Okay, now we'll talk a little again. Last week we talked a little about CDFs and PDFs. Again, to remind you, if you have something, you want the probability of, let's say, x is less than some number. Well, let's say, yeah, a is less than x, some number. Okay, if you plot that, it looks something like this. Okay, this is 1. It goes to 1, starts at 0. There's a certain, and then if you take the derivative of that, you get something that's called a CDF, which is what we talked about last time. Okay, a typical one looks like this. Trying to draw like a bell curve. Well, here's what the normal curve looks like. It's a Gaussian. It's you can see that it has 2 parameters: the mean mu and the standard deviation sigma. That defines the shape of the normal curve. In a normal curve, the areas represent probabilities, and as we said last time, 1 sigma is 68%, 2 sigma is 95%, 3 sigma, it's 99.7%. Okay, that was just a little reminder and a little formal definition of what that is. We'll be back in a second.
One of LearningMeasure.tv's sponsors is TradePub.com. TradePub.com is a site where one can sign up for a large number of free trade publications. If you'd like to support this podcast, go to the LearningMeasure.tv site, scroll down to the free publications link, and choose one of the magazines or one of the publications or one of the categories, and sign up through that link. Each publication subscribed to through this link on LearningMeasure.tv website helps keep Learning Measure TV on the air. Thank you for your support.
The next concept I want to discuss is something called expectation. When you're making a measurement of some sort, any type, you're going to have a probability of getting a certain value, let's say probability of x. Say there's just straight values, xi, let's say. Well, what's called we do know that the sum of the probabilities of getting some value must equal 1. Well, what if we did the weighted mean, weighting by the probabilities? We'll call this E for expectation. It's the sum of the probabilities of xi times xi over the sum of p of x, the probabilities. But this equals 1, so this is equal to the sum of the probabilities. That value is called the expectation. It's the value you expect to get from a measurement. Now, all kinds of interesting things can be get from expectation. For instance, if expectation, if all the probabilities are equally likely, let's say there's n probabilities. Let's say this is I equals 1 to n. Okay. Well, if all these are equally likely, this is 1 over n. Well, what's that? That's the arithmetic mean. That's the average. So taking an average, all you're saying is that each of the values you measured are equally likely. If that's the case, then this is meaningful. It may not be meaningful for other cases, but you can also have other probabilities that are associated with the sum. I'll give you an actual real example. Something called the particle box in a box in quantum mechanics. A certain state of a particle in a box has a probability of being found that looks like this. Okay, yeah, these should be symmetric, but I'm not a good artist. Well, as you can see, with this, you can guess the expected value is right here, 0. The probability of measuring 0 is 0. So the expectation might not actually correspond to an actual real measurement of something. For instance, if you draw another example, would be rolling a 6-sided die. If they're equally likely, the average of the expectation of the average measurement or average roll, if you roll a whole bunch of times, divide by it, is 3.5. Well, that's a value you will never roll. But this is still a meaningful concept, expectation. I just wanted to make this a little short episode, so we did something. It's really getting hot in here because I have to turn on the bright lights to do this podcast, and it's getting very warm. So anyway, if you would interested in suggesting something topic to cover in this podcast, as always, send us your suggestions to suggestions@learningmeasure.tv, and if you want to be on the podcast, send your your emails to vendors@learningmeasure.tv. Don't know what we're going to go over next time. It'll be longer than this. I have a technician coming over today to fix the air conditioning. Hopefully we won't have a problem with the next episode. Okay, thank you. See you next time.